All right, so this is a help on question D. Okay, so for question D, we're going to evaluate this model. This is our model. We think that this predicts this data, right? Okay, and overall, it sort of looks like an exponential decay. But the real question that we have is our children learning? The real question is do these values of k stay constant, right? So look at your values of k, right? If they do this, if it's like 0.0037, 0.0035, 0.0038, 0.0032, if there's no pattern, right? 3, 6, if they just sort of bubble around, well, maybe it's right. Maybe there's just some random error, right? But if they do something like this, 0.0037, 0.0035, 0.0033, 0.0031, if there's a monotonic decrease, that is, it decreases or increases, and it does that, does it 1, 2, 3, 4, 5 times in a row, right? Then you have like a 1 and 2 to the 5th chance that that's actually random, okay? So look at that, talk about that, right? Okay, so that's the first part, is just discuss this, talk about your values of k, and do the k values stay constant, right? The second part is sources of error. Why might it not follow that rule, right? That assumes that conduction is the only thing going on in that beaker, but the beaker was open to the room, right? There could be evaporation going on. There certainly could be radiation going on. We could have spillage. So possibly, there it is, right? And then, so that's the second part of the conclusion, right? And then the third part of the conclusion would be, how would you prevent that from happening? I can think of a way to prevent evaporation from happening, for example. So identify a couple sources of error, right? And figure out ways that you would ameliorate those sources of error. Okay, so that's question D.